Hi guys, welcome back to my channel. Today we're going to be looking at finding the inverse of a 2 by 2 matrix. So we talked about this a little bit in the last video, but due to the way that matrix multiplication works, we can't just simply reverse that process to find the original matrix. What we can do, however, is we can multiply by the inverse matrix. So we can think of this as multiplying by a half rather than dividing by 2. So this has a special name. This is called the multiplicative inverse. So that's just a really fancy way of saying dividing, but we're not dividing, right? So it's the multiplicative inverse. Now, if you take a number and you multiply it by its multiplicative inverse, you should get 1. So for example, if we did 1/2 times by 2, that's equal to 1. So matrices actually have a very similar property. So when we multiply a matrix by its multiplicative inverse, we should find that the product is equal to the identity matrix I. So for example, if we had a simple 2 by 2 matrix and we multiplied it by its multiplicative inverse, that should be equal to 1, 0, 0, 1, which is the identity matrix for a 2 by 2 matrix. So there's a special formula that we can use, and this is a little bit of a tricky formula. So the inverse of the matrix is going to be equal to 1 over the determinant multiplied by D negative B negative C A. And I know this is a tricky formula to try and remember, but it's really not that bad. So think of it as 1 over the determinant multiplied by our matrix. And with this matrix, A and D have swapped spots, B and C have swapped signs. So that is my little trick to help you to remember this formula. So A and D swap spots, B and C swaps signs. Let's go ahead now and do an example. Determine the inverse of the matrix R is equal to 2, 3, negative 1, 5, and verify that R times by its multiplicative inverse is equal to the identity matrix. Okay, so let's go ahead and let's write in our formula first. So our multiplicative inverse is going to be equal to 1 over the determinant. So remember to do that. We're going to do 2 by 5, which is the same as AD, take away BC. Then we're going to multiply that by our new matrix. So remember, with our new matrix, A and D are going to swap spots, and then B and C are going to swap signs. Okay, so let's substitute in the information that we know now. So to calculate the determinant, 2 by 5 is going to be 10. Negative 1 by 3 is going to be negative 3. So 10 take away negative 3 is going to be equal to 10 plus 3. All right, so now let's go ahead. So A and D swap spots. So 5 is going to go here, 2 is going to go here. And then B and C are going to swap signs. So positive 3 will go to negative 3, and negative 1 is going to go to positive 1. Okay, so now we can complete our matrix. So we have 1 over 13 times by 5, negative 3, 1, and 2. And we can apply this scalar factor. So this becomes 5 over 13. Oh, I should have made my matrix probably just a little bigger there. So 5 over 13, and then we have 1 over 13, negative 3 over 13, and 2 over 13. So there we go. So that is our inverse matrix, or our multiplicative inverse. So let's go ahead now and let's verify that when we multiply the original matrix by the multiplicative inverse, that we get our identity matrix. Now, since this is a 2 by 2, what we're hoping for here is going to be our diagonal of 1s and our upper and lower triangles there of 0s. So that's for our identity matrix. Okay, so let's write this out. And let's go ahead and perform this multiplication. So just to start with, I'm going to continue to use this highlighter just so that you can see which parts I'm going to be multiplying. Just as a reminder too, when we're doing matrix multiplication, this is a 2 by 2 matrix and this is also a 2 by 2 matrix. And so when we multiply these two in this order, we are going to be left with another 2 by 2 matrix, just as a little refresh there for you. So now that I've gone and performed this first little step of multiplication, let's go ahead and let's do the next one. So now what we're going to do is going to be 2 by negative 3 over 13. Let's finish this off screen. All right, we've finished with that top row, so let's go ahead and have a go at the next one now. And then let's go ahead and do our final column. Okay, so now we can go ahead and we can do all these calculations, and I'll come back with the answer for you. Okay, and there you go. So the matrix does simplify to the identity matrix, which is fantastic for us because that means that we have calculated our multiplicative inverse correctly. All right, so that is how we use determinants to find the inverse of a 2 by 2 matrix. See you in the next one.